Hello all. In this session, we see the synthesis of nanomaterial. That is, different approaches for the synthesis of nanomaterials. There are two approaches. One is top-down and bottom-up approach in nanotechnology. So nanotechnology is designing, developing, or manipulating at nanometer scale of any material. The dealing object size should be less than 100 nanometers, at least in one dimension, to call something to be a nanomaterial or which involves nanotechnology. There are two design approaches in nanotechnology. It is top-down and bottom-up method. Both the approaches have a different advantages and disadvantages and a different types of applications. You see, what is a top-down method? There is a bulk material, and the bulk material is broken down into a smaller fragments and to the nanostructures. That is, a larger one is broken into a smaller one. We call it as top-down method. And we are aggregating or consolidating a small atoms to a nanocluster into the nanostructures. We call it as bottom-up method. So the top-down method, there is a transformation of energy from bulk to a small size materials. And bottom-up method, a small size atoms can be converted to a nanoscale. So top-down methods are several types, which is mechanical milling, etching of a material, laser ablation, sputtering, electro explosion. And bottom-up approach have a supercritical fluid synthesis, spinning, sol gel process, laser pyrolysis, chemical vapor deposition, that is CVD, molecular condensation, chemical reduction, and somewhat a green synthesis. So in top-down approaches, it begins with a pattern generated on a large scale, then reduced to a nanoscale. It is a relatively expensive one and a time-consuming technique. The approach uses a large initial structures, that is macroscopic structures. So in this method, the structures can be extremely controlled in the processing of your nanostructures. So the top-down approach made by processing large objects in small size. The starting material in these fabrications are relatively a large one. For example, you can see such as silicon crystals. Lithography is the technology which enables making such tiny chips, and there are many types of them used in photoelectron beam and ion beam lithographies. The top-down method, nano gold, nano silver, nano titanium dioxide, can be made into a different application. Carbon nanotube manufacturing process using the graphite in an arc oven method is the best example for top-down approaches. The another approach is bottom-up approach, starting with an atom or molecule and build up the nanostructure. The fabrication is much less expensive. It includes miniaturization of materials, components, leading to the formation of a nanostructure. During self-assembly, the physical forces operating at the nanoscale are used to combine basic units into a large stable structures. In the bottom-up approach, nanotechnology is making a large structures from smaller building blocks such as atoms and molecules. Self-assembly, in which the designed nanostructures are self-assembled without any external manipulation. And when the object size is getting smaller in nanofabrication, bottom-up approach is an increasingly important component to the top-down technique. In the bottom-up approach, the manufacturing of carbon nanotubes using a metal catalyst polymerization is a good example for this approach, particularly the bottom-up method. The major difference between the top-down and bottom-up method in nanotechnology is The manufacturing process starts from large structure in top-down approach and it is small structures in the bottom-up method. Bottom-up method manufacturing can produce structures with perfect surfaces, but in top-down manufacturing, not such perfect structures can be obtained. It has some wrinkles and contains some cavities. Bottom-up approach manufacturing technologies are newer than top-down manufacturing and expected to be alternative for its some applications. Bottom-up approach products have a higher precision accuracy, therefore can manufacture smaller structures compared to the top-down approach. And finally, in top-down approach, there is a certain amount of wasted materials as some parts are removed from the original structure. Contrast in bottom, we have an assembly of a small materials to a larger one. So the wastage is being reduced. So most probably the bottom of the ridge is found to be a better one than the top road. But depending upon the different nanoparticles, such as nano rod, nano wire, nano cluster, carbon nanotube, both has some equal importance when the structure is controlled and regarding the applications. Thank you.